Hi everybody. Now I'm looking at section S.2 in the stats section of Foundations of Math 11. So the last class we looked at the range of data sets as a way to give us an idea of the distribution. But that's really simplistic. It only looks at 2 data points. Another way is to look at the frequency distribution of the data, which is to group the data into smaller into intervals that are usually the same size. So for example, the grades from a Math 9 class's first unit test are shown in the table below, and we're going to generate a frequency distribution table for the data. Now, technically, well, let's do the way we'll actually do it, which is we're going to say, if I look at the data, there's nothing that's below 40, so I'm just going to make that from 0 to 40, one range. And the next one is going to be, 40 to 50. And then 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Now, technically, what do you do if the score is 40? Which one does it go in? So technically what it should be is that this one where I'm saying it's 40 to 50 is anything that's going to be greater than 40 and less than or equal to 50. And then this is going to be anything that's bigger than 50 and less than or equal to 60. But that gets really cumbersome to do it that way, so we generally just don't bother writing it that way. We all understand that that's what it means. And if you read the fine print down here, it says we normally do 5 to 12 intervals. So we divide it into 5 to 12 chunks. Too few doesn't separate out the data enough to be useful. And if it's too many, then what's the point of grouping the data? It doesn't help either. Sometimes the range is divided into 5 intervals because we want 5 intervals for a particular reason. Sometimes the data we divide it according to something that makes sense. So for example, when we talk about how people do on tests, we sort of look at a 10% range, so it makes sense to go from 40 to 50, 50 to 60. That just kind of makes sense, so we chose to use that as the interval. And then this is just the thing I said about the it being really cumbersome to write out the technically correct definition that I have there. So in this course, we're going to assume that the lower limit is not included. So anytime I say 50 to 60, it means anything that's bigger than 50 up to and including 60. Okay, so that's just going to be an understanding that we're going to have. That's what the textbook uses, or the work pages use. Okay. Okay, and the intervals should be equal, although that doesn't always happen. Often the first one and the last one are bigger because they often don't have much in them, so it doesn't make sense to split that up. It makes your table more big and awkward, and your graph, which we'll get to later, just looks silly. So we just group the ends together. Okay. All right, back up to our table. The best way to do this now from here is to what I do is I look for anything that ends in 0. Okay, so looking at my data, I've got the 60 here. So the 60 is going to go in this one here because that's 52 and including 60. So I'm going to put a tally mark and I'm going to cross out my 60. And then it gets easier. That's the only one I see that ends in a 0. So now anything that starts with an 8 goes in the 80 to 90. So I can just go through and I'm going to count how many, because this starts with 8. So it's 1, 2, 3, 4. So I saw 4 that started with 8. 1, 2, 3, 4. And then I've got, I'll do this in a different color. So starting with 5, I've got 1, 2, 3, 4 that started with the 5. 1, 2, 3, 4. And I already had the 1 in there, right? Because 60 is part of that group as well. Let's do the 6s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Lots of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 7s, 1, 2, 3, 4. And then I've got 1 in the 40 range and 1 in the 90 range. And then and then I go back to check to see if I missed any because I was crossing them out as I go. And yes, I see that I missed this 46, so that's 1 and a 42. So I've got 2 more in the 40 range. Okay, and then it's really important, again, error checking. You know, I'm really big on doing that as you go to total it up. So I don't know why it's doing that. That's really going to get old. Okay, well, let's do this. So there's 0 there. There were 3, 5, 11, 4, 4, and 1. And then I'm going to take my calculator out, add those all up, and see that I get the same number I started with, which was 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 28. And yes, that does total 28. So yay. Okay, next page. Okay, although the frequency distribution table is useful, it's often easier to interpret this information if we put it into a graph. So I've just copied the table from the previous page so that you don't have to flip back and forth, and we're going to create a histogram from this. So I'm going to label, this is going to be histogram of Unit 1 test scores. And down here I have test scores. And I just happened to make the graph just the right size that each 2 tick marks is 10%. So there's 10 and 20. And then up this side, I'm not going to try and write it sideways. Frequency. And it starts at 0, and again, I just, because I've already done this, I can conveniently divide this up by 2s. Remember, you don't have to put a tick mark and a number for each number along this axis. They just have to be evenly spaced, and you want them to take up as much of the graph, of the grid as possible, as it makes sense. Okay, so from 0 to 40 we had 0, and then between 40 and 50 we had 3. So I'm going to draw this up to here. You are expected to use a ruler. A ruler is just not going to work with the software that I'm using. So, well, actually, now that I say that, I think there's a way to do it, but I will find that out for next time. Okay, so from 50 to 60, it goes up to 5. From 60 to 70, there's 11. 70 to 80 is 4. 80 to 90 is 4, and 90 to 100 is 1. So I'm just going to shade those in. So this lets us see the data more clearly, certainly than the raw data list. We see that most kids got between 60 and 70, and that's really easy to see by looking at the graph, or the histogram. Okay. And because this includes all the data, the bars are going to be right next to each other, because it covers everything. There's no gaps between the bars. Okay. All right, and then we're going to look at something new, probably, that's called a frequency polygon. And a frequency polygon is a line graph with a point representing the frequency at the center of each interval. Frequency polygons are very helpful with comparing multiple data sets. because you can draw them on the same grid. You just lay them one on top of each other. That question will be on your quiz. That question will be on your test. Why are frequency polygons more useful than histograms? And the answer is that they are good for comparing multiple data sets because they can be drawn on the same grid. Okay, you have been warned. Okay. Example 3, use the frequency distribution table from example 1 to generate a frequency polygon. So we're basically going to use the same data from up above, which is not on the screen anymore, but you have it on your paper. So we're going to set this up the same way. This is now going to be a frequency polygon. Of Unit 1 test scores. And this is the test scores down here. This is the frequency. Okay, so far this is the same as the other one. What we're going to do this time that's a little bit different is we're going to put our dot in the middle of the range. So for our 30 to 40, for 30 to 40, we had, I'm going to do this in a different color. For 30 to 40, we had 0 data points in there. So I'm going to put a little dot there. And then between 40 and for 40 to 50, we had 3. So halfway between there, I'm going to put a dot at the 3. And then we had 5 between 50 and 60, so I'll put a dot at the 5. And then between 60 and 70, it went up to 11, and then it came down to 4, and 4, and 1. And then I draw, connect those with a line, draw a line. Yeah, there's the line. Okay, so I can do a line from there to, that might not be worth it. Okay. I will just draw a line, but I do want you to use a ruler for this, okay? Okay, and then I'm going to just change the view on this so that you can see the whole, you can see both of those at the same time. So you can see that they have the same shape, right? They still convey the same information. We can still see that between 60 and 70 had most of the scores. But we're going to look at the example. The next example is going to show us what it looks like with one on top of the other. Okay. So the next page. All right, your turn. So you're going to do this graph on your own. You're going to copy the same graph that we did on the first page onto this, and then you're going to do this new test score on top of that, okay? And I'm going to pause this video to give you time to do that.